Hello there and welcome to another rebuild series. Today we're going to be working on a Ford C4. It's going to be going into a 1967 Ford Mustang that's also going to be equipped with a brand new Blueprint Engines crate motor making about 300 horsepower or so. So what we'll do today is walk through part selection, build considerations, and then I'll show you some lube mods that you can do that'll improve oiling flow throughout the unit, and then from there we'll get into the build-up. So let's go ahead and get started. Alright, I'm not going to dwell too long on part selection. This is going to be a fundamentally sound build for what I would call a mild performance application. So we're going to have a few choice upgrades, but everything else is going to be largely stock. So we have our bolts and small parts here on the bench, an overhaul paper rubber kit, and then the transmission came in with a Sonex billet servo assembly for second gear. So if you have such a situation in your build, you want to get this seal kit here. It's going to be K13259C, and this will have the 2 lip seals and the gasket you need for that assembly. Alright, we did replace some bushings. I didn't replace 100% of the bushings like I usually do, and that is because some bushings are not available, or in the case of the reverse drum, that bushing almost never needs to be replaced, and you need a very specialized installation tool to install the new one once you remove the old one. So again, I wouldn't bother. So for 1960s C4s, I'm having real trouble locating a brand new rear stator bushing. None of the suppliers I work with seem to have them. They cannot get them. I don't know what the story is, so just be aware of that if you find yourself in that situation. Take your input shaft, insert it into the stator shaft, and then kind of move it from side to side to see if there's excessive play. If there is, then you're going to either have to replace the bushings, finding new ones, or replace the entire stator support assembly with a good used one that has good bushings already in there. Alright, you can also install new pump gears. These are from the aftermarket. I bought a set thinking I may do that, but I'll be honest, I would prefer to reuse the factory gears if they're in good shape, and these are. After scrutinizing them, the only thing that concerned me was there was a slight ridge here on the flats for the torque converter. I just took this small fine file and just kind of knocked down the ridges, and it'll have no problem working as it should. So, and that's the drive gear. All right, let's see, new modulator, Transgo shift kit. If it doesn't already have one, which I don't think it does, we'll go ahead and put that in, and then that's basically about it for the front. Now, one thing I would advise you to do is have a variety of different selectives on the bench for your number 1 and number 2 thrust washer position. This is the number 2 washer. This is going to regulate your end float, and then this is the number 1 washer, and this is going to set the spacing between your direct drum and the back of the stator. So the number 1 washer is contingent upon the number 2 washer, so you would base your selection of the thickness for your number 1 washer as per what you've selected for the number 2, and we'll show you how to make that selection for the number 1 when we get to that point in the assembly. Okay, clutches, steels, and bands, pretty straightforward deal. As you can see, I have a variety of different modules on the bench, at least for the direct clutch. Forward clutch, we're going to go Alto Reds, and we have 5 and 5, so 5 steels, 5 frictions. The steels that came in with this unit for both clutch packs are in very good condition, so there's actually no reason to purchase new steels. Alright, there's the forwards, here are the directs, and as you can see, the clutches are also in very good shape. So if you wanted to, you had a unit come in cherry like this, you could reuse those clutches and not have a thing to worry about. But with that said, I like either the high energies or the altos for the direct. This happens to be a 4 and 4 drum, meaning 4 frictions, 4 steels. So I'm not 100% which one of these I'm going to install. I'll make the decision literally as I'm going through it. So you'll get to see what I decide and probably be there for the decision. Alright, nothing really remarkable to discuss for the rest of the case. The 2 bands were in excellent shape, so we're going to reuse those. We're going to install a new low roller clutch and spring kit. So you have your rollers and your springs, and then they go into the cage, and you'll see how that process is and what a pain in the ass it is to get these installed. I'm not going to film the entirety of it. I would bore you to death, but suffice to say, there are no unified assemblies. You have to install the new roller and spring kit. Alright, the rest of the stuff in the back of the case is going to be stock. We have a replacement low reverse servo piston here. I believe the previous builder also replaced it, but I'm not going to take any chances. I'm just going to put a new one in. New bushing here in the ring gear for the front. New bushing in the case, as well as the sun gear. So 2 new bushings. And then the direct drum also received a new bushing. This bushing back here in the reverse drum, you do not have to replace in most cases. I would say 99.9% of the time, you can just leave this alone. You'll need a very, very specialized bushing driver of sorts to install the square and true, because even with the old bushing, when you try to fit your cam in here, I mean, you can see it just fits like a glove. I mean, there's basically enough play between the outer diameter of the cam and the inner diameter of the bushing to allow for a thin sheen of transmission fluid, and that's basically it. So like I said, very rare you have to replace that bushing. Alright, so that covers part selection. So let's go ahead and reorganize the bench a little bit. I'm going to bring the case front and center, and as well as a few other parts, and we'll talk through lube mods that you can do. Alright, I'm not going to do all the mods that I'm going to suggest here, because frankly I don't think that they're all 100% necessary. The one thing that I would suggest you do though is drill out the return cooler line passage in the rear of the case. So that's going to be this location right here. As you can see, I've wallowed that out. You can go anywhere from 3/16 to 1/4 of an inch. Matic Dynamic prefers 1/4. That's what I typically do based on guidance from him. And then the other mod that's real popular is folks like to drill out the oiling hole for the sprag or roller clutch assembly. Let me get a flashlight. Alright, hopefully you can see down in there a little bit better. So there, roughly the 9 o'clock position is going to be that oiling hole for your roller clutch assembly. I'll be honest, I don't know if there is a whole lot of efficacy to the argument that that should be drilled out. Some builders do, some builders don't. Jay at Broader Performance suggests that if you're going to do it, don't drill it any more than 1/8 of an inch. Otherwise, you will lower oiling pressure there in the back of the case, and the front of the gear train, including the planet and ring gear, may not get sufficient lube flow. Now, if you're going to run a bearing here, then maybe there's more of a case to open this hole up a little bit. And again, Jay has a video where he talks about having a bearing here fitted to a press fit locating race of some sort. You'll have to check out his video. It's on his channel. He gives you the part number for the bearing, as well as a very thorough description of exactly what he's talking about and the modification that he's suggesting that you do there. Alright, one thing you want to watch out for all these C4s as well is you want to make sure that this vent passage or exhaust passage is not blocked, clogged, or restricted in any way. I've never seen one come in like that, but apparently it's a something that some builders do. They'll modify this possibly for full manual operation, but either way, if it's plugged and you're running a normal automatic forward shift pattern transmission, and that's what you want to do, I would ensure that this is not plugged or restricted in any way. And again, I'll refer to Jay at Broader Performance's video. He has a topic on this as well, and he also shows you some of the things that folks have done to aftermarket servo assemblies that mitigate the risk of issues that can occur with this thing being plugged. Chief among them is where you have a massive lockup when the transmission attempts to shift in the third gear, where the band is not releasing it all, and then well, you have major problems should that occur. So the last oiling model I'll discuss has to do with the sun gear. Some folks have talked about opening up a few of these lube holes, and so you can do that. To what extent you want to open them up is up to you. Like I said, for most factory to mild performance builds, it's not really something that I think you need to do, but it is something that I've seen come up in discussions on internet forums where folks have talked about, you know, doing that particular mod. All right, the last mod I'll talk about is to the stator. So you notice here, in this little orifice, and let me see if I can zoom in on it so you can see it. There's going to be a little spring in here, and this spring is holding in 2 check bowls in position. So what this is a cooler drain backstop. So in other words, it mitigates loss of fluid out of the converter when the vehicle sits for a long time. It also, to some extent, attenuates or dampens cooler flow throughout the unit. So what is very popular to do is to extract the spring, drill this hole out a little bit so that once it's big enough, you can get in there and push this plug out just enough to allow for the 2 check balls to come out. And in the 60 C4s, there were 2 balls in there. In the 70s, they installed 1. And in the 80s, when they went to the C5, they eliminated this feature altogether and have the stator such that it resembles a modded C4 stator with no balls or spring and just a plug, or I think it's a 1/8 NPT plug, which people will drill and tap this. You know, they'll pull this end plug from the factory all the way out and then just drill and tap and plug it with their own, you know, their own fitting or whatever. So anyway, that's lube mods, and if you want to see a more comprehensive treatment on all the different oiling mods you can do, as well as demonstration, just let me know in the comments, and when I can, you know, when I get another C4 in there, it's a good candidate for such mods, I'll go ahead and do a video on it. But anyway, let's go ahead and start the assembly process and get going. All right, now we're ready to work on the pump. So I'll go through a couple of key points of inspection, things that you really need to look out for, pay attention to when it comes to scrutinizing your pump. And then we'll get into doing a clearance check using our feeler gauges and that little machine piece of bar stock. And then from there, we'll go ahead and put the pump together, because the last step, you know, assembly, is very straightforward. It takes all of, you know, 5 minutes or so. All right, from an inspection perspective, you want to do a visual and a physical inspection of your pump body and your pump stator support. So let's start with the body. Area that is going to be worn here, if there's going to be any area that's likely to be worn and imperil the job if you don't catch it, is going to be wear on the crescent. You want to check that, especially this leading edge right here. This is where I see them worn a lot. And that's true of all crescent style pumps, not just C4 pumps. So that's C6, AOD, 4L80E, TH350, 400, and so forth. All right, the other area you want to scrutinize real closely is the bridge between the suction and pressure sides of the pump. Okay, scoring on the working surface down here and behind the crescent is going to be very obvious. I mean, as soon as you look at it, you'll notice it, but it's this area here that can, you know, be deceptively worn. In other words, it'll look good physically and visually, but when you put either a set of feeler gauges and a little piece of bar stock or a depth micrometer into this area, and you measure the depth between the deck and the pocket here versus some other areas, you may see significant variance. So you just always keep that in mind, and you want to check for that whenever you're working on one of these pumps. All right, the other area you want to look at is going to be this inner diameter of the pocket wall. If this is scored up or if it's just excessively worn, then you're going to have excessive clearance between the driven gear and the wall, which is not going to be you know, beneficial at all for your build. The pump will not nearly work as efficiently as it should be. One last thing I want to make mention of, because I didn't cover it, is the orientation of your bushing here for the pump body. You'll notice that there is an oil groove, and you also notice that oil groove does not go all the way from one side of the bushing to the other. It terminates, and so you want to make sure that you arrange your bushings so that the opening of the groove is facing the gears. Okay, you do not want this groove facing out, because if so, it'll flood the front seal with all of that fluid coming in from behind it and possibly force the seal out, or at very least create a leak there. And you'll have to take the transmission out, take the pump out, and reorient the bushing. So other areas are, you know, more or less common sense. Just look over the whole thing structurally, make sure it's sound. And as you can see, this particular pump has a casting number just like all of Ford's parts and components manufactured over the years. RF stands for rough foundry, and C4AP is really the 4 characters you want to pay attention to. So the first character is always going to be an alpha character, C, D, E, or F. That denotes the decade of production. So C is 1960s, D is 1970s, E is 1980s, and F is 1990s. Okay, the integer, which is always going to be in the second position, is going to indicate the year of production. In other words, the year that this part was produced. So in this case, we have a 4. That stands for 1964. Okay, the A is going to indicate application. Now, it doesn't stand for application. It just simply indicates what particular model or submodel this part was intended for. And the letter A is just a generic designation to indicate Ford. And then the P is going to represent the design office within Ford that's responsible for engineering producing this part. So P is always going to indicate the automatic transmission design office within Ford Motor Company. All right, so that's the body. I guess lastly, you want to make sure during the cleaning cycle removed any and all debris from these passages here. Okay, these are going to be your passages for your apply circuits and converter feed. You want to make absolutely sure that they are all free of any kind of grime, dirt, contaminant of any kind, nature, or sort. All right, for your stator and stator support assembly. All right, we talked about the bushings. They can be very hard to find, if not impossible, for the 60s vintage C4 pump stators. Fortunately, most of the time, these bushings are in good shape. You don't have to mess with them too much beyond just checking them using your input shaft. But every once in a while, you'll get one, especially back here at the rear stator position, where it is just excessively worn or scored up. And unfortunately, at least to my knowledge, you cannot find new reproduction rear stator bushings for the 60s era C4s in the aftermarket. They're just simply not available. All right, you want to scrutinize your splines. Okay, that's more or less common sense, and you want to basically look for what I will call winnowing here in the middle portion of the spline, where it's wide at the end here and here, but then it starts to narrow where it actually engages the torque converter splines. And if you see that, you know, this will have excessive play in it, so to speak, and you may not want to use that particular stator half. All right, check your working surface. A little bit of visual witness marking like this is fine. Run your fingernail across. Make sure that you cannot feel anywhere any scoring, where if you're running your fingernail and it's getting caught, you know, it's getting hung up in a particularly deep groove. If so, you'll just want to machine this. You know, you can chuck it up on a lathe, turn it down. What most folks will do is anywhere from 5 to 10 thousandths of an inch in real extreme cases, but you usually don't have to take off much at all. All right, check your journals. Make sure that the journal here is in good shape. You can take some 400 grit, then 800 grit, then 1500 grit, and just simply sand it down. You can wet or dry sand it. You can use transmission fluid. Whatever you want to do, just make sure that it is in good shape so that it doesn't prematurely wear out the direct drum bushing. All right, this is going to be a little lube hole right here. All right, this is going to become critically important for when it comes to installing this pump. You do not want your number 2 thrust washer to be obscuring the lube hole. So for example, when you install the number 2 washer, you want to make sure that the little cutout in the washer is over that lube hole. All right, then check structure. And here we see another codification indicator. This one looks like it's production year 1967, so 60s, the year is number 7, so 1967, and an AP. So like I said, you'll find a hodgepodge of parts in most of these older units when it comes to the year of production. I will say it's almost impossible to know exactly what year a specific transmission was produced in. The best way to go about it is look at your major parts, like the pump or the case or the valve body, and whatever the most recent date that you see cast into, you know, whatever that part is, might be a good indicator. Might be. I'm not saying it is. It might be a good indicator of what year that transmission was actually manufactured. Now, there's going to be some characteristics too that will help you differentiate. For example, the 64 to 66 were the so-called green dot years, and so you had the dual range valve body design installed in those 2 years only. So if that's what you have, then you can assume you're working on a 64 to 66 unit based on the valve body design there. All right, let's take a look at pump gears real quick. So when it comes to the gears themselves, most of the time, if a unit comes in largely unremarkable, maybe it's got a, you know, a fried direct clutch or something, but you know, there was no hard part damage, there was no significant overheating, no converter failure where metal would have been passed through the pump, your gears should be in good shape. But the things you want to check for are the wear patterns on the teeth. So both sides of your teeth for both your drive and your driven gear, as well as the crest of each of the teeth. So you want to make sure that there is no signs of wear to where, like, you see fracturing, you see heavy kind of like really shiny spots that you know, where you start to see little cracks appearing in the gear. I've seen that before a few times. This drive gear has what I would call normal wear pattern. Okay, look at the face of the gear as well. You see normal wear pattern, witness marking, etc. Nothing to worry about. But on the drive gear specifically, where you really want to scrutinize is the area of the torque converter engagement flats. So you see we have the converter on the bench. When you're going to install your pump or put it together and you have your gears in the pocket, the flats for the drive gear will face up or face you so that the beveled side can face the torque converter. And then you just simply want to take the gear and slide it on the converter. It should have a nice tight fit, but it shouldn't be bound. Okay, that fits really, really nice, but there's no play on that gear between it and the converter hub. Now, do not do this if you don't have your new converter yet. If you don't have your new converter yet, you can use a checking tool that's made the proper dimension. Or what you could do is, you know, if you have a converter builder, just have him make you a checking tool out of another C4 hub that's in either new or perfect condition. If you use the old converter, a lot of times they have scoring on them, the hubs here, and you might mess up the gear. And if you're going to check the body bushing, which I've already done, like for example, if you want to put the body onto the converter and check it, if you have your old gear, if you have your old converter and there's scoring on the journal here, then it's going to mar up your bushing. So if you have mushroomed flats, in other words, where you can see here, you start to see the beginnings of a little bit of mushrooming here on the points of engagement with the torque converter on the drive gear, what you could do is take a very small, fine file, and I'll grab the file that I actually used on this gear, a very small, fine file, and carefully go over the flats, just like this. I go one way, and that should knock down any minor mushrooming. If it's significant to where you couldn't put this gear onto the converter hub, you know, your brand new torque converter, then this gear would need to be replaced. Now, there are aftermarket gear sets available. My preference is to use the original gears, even though they may have like 1,000,000 miles on them or whatever. My preference is to use the original gears as opposed to the aftermarket gears. All right, I mean, I'll be honest, I've never had a failure with aftermarket gears, but I've read numerous accounts online, and other builders have told me that they've had issues with some of the gear sets that are sold, in the aftermarket by various distributors and part suppliers. All right, let me think if there's anything else. Driven gear, you want to make sure that there is no scoring on the outer diameter of the driven gear. As you can see, this one is in basically cherry shape. All right, no cracks, no fracturing. Okay, and then you notice there's a little dot here stamped into the gear. Okay, this dot corresponds to a bevel in the gear here on the top of the tooth. This bevel or chamfer and this dot face down into the pump. All right, I want to make sure I make that as a point of emphasis, because common sense, or at least from an intuitive perspective, you would think that any dot on a gear like this, or really any part that could go up or down in a housing, would indicate that the dot faces up, because that's how most of us think about these things. But Ford, for whatever reason, decided to index this gear and all these gears for the C4 such that it goes down or faces forward in the pump and not rearward. So just go ahead, put that in there, and then we'll put our drive gear, and again the converter flats face front, so they face down. And now what we're going to do is perform a clearance check. We'll show you two measurements that I usually do with these transmissions or these pumps, or really any kind of crescent style pump, gears like this. Okay, I'm going to measure the clearance between the face of each gear and the deck surface, and then I'm also going to measure the clearance between the driven gear's outer diameter and the inner diameter of the pump pocket. So I don't have a straight edge that can span this width here while at the same time fitting inside the recess, so I'm just going to use this little machine piece of bar stock. And then I have 3 feeler gauges here, a 1 thou, a 3 thou, and a 2 thou. So that's 1/1000 of an inch, 3/1000 of an inch, 2/1000 of an inch. What we want to see in terms of our clearance between gears is between, I think the specs 8/10,000 to 3/1000, but typically what you'll find if you have a set of gears and a body that are in good shape is a clearance between 1 and 3/1000 of an inch between the face of each gear and the deck. And then you want to be somewhere between 2 and 3/1000 or so between the outer diameter of the driven gear and the inner diameter of the pump pocket. So if you're having to use something like this, you want to make sure that, number one, you don't go over the crescent. Avoid the crescent with your straight edge or your little piece of bar stock. And then number two, you want to make sure that you hold it firmly here on the outer edge so that it doesn't drift forward and make contact with either of the gears. So you could do just a quick check and spin the gears. And basically you want to make sure that the gear set is not coming into contact with the little straight edge, or I'm sorry, the little piece of bar stock. If you have a straight edge, it's a lot more straightforward, but you really need to make an effort to hold the bar stock piece so that there is no contact being made, and that you don't feel anything on this while you're spinning your gears. So you can do it on either side, and sometimes it's difficult to get the gears turning, but I'll just take my thumbnail or fingernail and go right in here in between the drive and driven gear, and that's how I get them moving. Okay, now it's possible you can actually move the gears in such a way that they kind of raise up a little bit and make contact with your little piece of bar stock, so you want to avoid that. Alright, and it goes without saying, because I just showed you, whatever you do, do not put any kind of transmission fluid or assembly lube in here while you're doing this check. Alright, so it seems to spin freely. Now what I'm going to do is I'm going to check with my 1 thou feeler gauge and see if I could fit it underneath. Okay, it fits here under the drive gear. Seems to be a little tight under the driven gear. There we go. It fits, but it's dragging on both sides of the gauge. So both sides of this gauge are making firm contact between the face of the gear and the bottom side of this little machine block. Okay. So I'm just checking on all three sides just to be thorough. And again, if you don't have a depth micrometer, this is going to be your best bet. You'll notice that in this area over here, it seems like I have a little bit more clearance than I did over here. So we'll check this area again too. It could have been user error as well. Yeah, definitely a little bit more draggy here. So that's not a big deal. Like I said, unless you have a depth micrometer and you're measuring your depth at multiple points, it's very hard to quantify exactly what your clearance is going to be. These are basically what I would refer to as like a Boolean type test, where it's going to be a pass or a fail based on how thick a feeler gauge you can fit underneath your straight edge or block. So now I'm going to try 2000s and see what, if anything, I see differently when it comes to clearance. Okay, 2000 seems to fit okay. Okay, it seems to fit okay. It's starting to bind up around there. So there's the 2000s. Hopefully you can see that. Alright, now we'll do 3000s. Alright, 3000s is straight up not fitting. Yeah. Okay. So I'm satisfied that we have good face to deck clearance. Alright, now what we're going to do is I'm going to take my gears, I'm going to go like this, just kind of, grab and force the driven gear away from the side pocket there. And then what I'm going to do is I'm going to go around, I'm going to start with my 2 thou feeler gauge. I mean, it's visually obvious it's going to be thicker than a thou. Okay, what I like to do is I'll go like this, kind of lift it up and down to see if it wants to move the driven gear at all, see if it wants to bump the gear. Okay, this is fitting very tight, but it's not moving the gear. So let's see what 3000s feels like and see if that starts to move the gear at all. If I can get it in there. Okay, that is a very snug fit. Alright, that is very, very snug. So, let me see if I have a 4 thou feeler gauge handy. Generally speaking, you want to be 4,000s or less. I've seen 3,000s or less quoted as well. If you're way out, like 6, 8, 10,000s, then at that point you would need to, at minimum, replace your gear set. That would indicate the gear set is worn, and particularly the driven gear, but probably both of them. Okay, I could fit a 4 thou feeler gauge, but it's not wanting to go in any more than what I'm showing you. Alright, we'll go ahead and remove our gears. And then what I want to do is put my little support here. Alright, and this thing is a reaction shell from a General Motors 4T65E transmission. So if you're looking for something to support pumps and other things like this during assembly, I use this thing all the time. It's a great little tool to have. So lube up your bushing, your seal, and then everywhere in the pocket with assembly lube. You can also assemble the pump with transmission fluid. Now, if you're concerned about having issues on startup, if you're not going to use transmission fluid, once the transmission is fully assembled and you have the torque converter, you want to fill the converter with 1 to 2 quarts, just like I show here written on this particular converter. I write that on all of them. And then once you've done that, go ahead and install the converter. Make sure it's fully splined in correctly to the input shaft and the stator shaft. And then start spinning the converter and keep spinning it until you see oil dribbling out of the supply line fitting on the side of the case. Once you've done that, you will have successfully primed the pump and you'll have a wet start. And so assembly lube is just like a placeholder. All right, it's once you fire up the engine, fluid is going to be flooding the pump from the converter, lubricating it. But if you want a wet startup, priming it like I've just described will enable you to do that. All right, just gonna spin them a little bit round, make sure everything's good. And now as far as your stator, go ahead and lube your working surface. You don't need a ton of assembly lube, just a little bit, enough to get it nice and coated. And then what I like to do is just line up my 3 circuits here and line up my 3 balls here on the side of the stator. And that'll get me where I need to be when it comes to, bolts. All right, takes 5 bolts, pump the stator. You don't need any special alignment tools. I mean, as you can see, it just drops right on and into the recess. Makes this assembly nice and easy for you. So just use like a low power battery impact to run them down. All right, we got our torque wrench. So book calls for, I believe, 15 to 20 foot-pounds. I like to go right in the middle. Whenever there's a wide range specification, I'll start in the middle unless I have 0 experience on whatever I'm working on. And then I'll start at the low end and just see how the fastener feels as I'm tightening it down and torquing it up. All right, that out of the way. So you can go every other bolt until you torque them all. So it ends up being a crisscross pattern, more or less like you're tightening the lug nuts on a wheel where there's, 5 studs on the axle. So you just go every other bolt until you got them all. Alright, last order of business is the sealing rings. Alright, so we're not going to do anything with the thrust washers. We'll show you how to select the number 1 washer a little bit later once we have both the forward and direct drums fully assembled. But as far as your sealing rings go, these rings, while they may appear to be the same at a glance, they're actually not. So this set right here is going to be for your forward drum. And the aftermarket will color code the sealing rings so that when you see a sealing ring with two colors on it, in this case we have a yellow and a red mark, that would indicate that this is for the forward drum. Your direct drum, or at least the sealing rings for the direct clutch apply circuit, are only going to have one color mark on them. So, in the case of these two, it's yellow. The other thing you could do is just simply put them together and compare them in terms of their diameter. And as you can see, the forward drum's sealing ring is going to be a little bit smaller than that for the direct drum. So color and size are going to be your best bets here for determining which set of sealing rings go in which set of grooves. So this is going to be your forward drum, and this is going to be your direct drum. So we're going to install the larger, thicker of the two sealing ring sets here for the direct drum, and then the other two for the forward drum. The forward apply circuit will go right here. Alright, so you want to be careful with these cast steel rings. Just kind of ease them over and maneuver them. Be careful on the journal too. You don't want to mar up the journal by dragging the two ends of the ring, scraping the journal all the way down. Just open up and then install them just like that. Pretty simple and straightforward deal. Okay, now we'll do the forwards. Alright, and as far as I know, there's no clocking required, so the ring gaps, or the joints rather, don't need to be oriented in any particular way with respect to each other. It's not like sealing or rings on a piston where you want the top and bottom compression ring kind of staggered so that the gap in the rings don't align. So this is much simpler. Okay, so now we have our pump fully assembled, and we're ready to move on to the two drums. So now we'll go ahead and move to the forward drum. I got two different Belleville plates, we'll talk about that. And then we got to get our steel module and our backing plate and apply plate out. So the forward drum is always on when you're in a forward range position. If you take it out of a forward range position, it'll come off, but it's always on otherwise. So best practice here is to run the clearance as tight as you can while still remaining in specification. So the specs for both the forward and the direct clutch for clutch clearance are 25 to 50 thousandths of an inch. But I can tell you, if you're on the higher end of that for the forward clutch, you will put the Belleville plate at risk. All right, that plate travels an awful lot, and there's a lot of flexing, if you will, that it has to experience over and over and over and over again. And so the more it is allowed to travel and the greater the extent of the flex, the more aggressively it's going to wear out. And so I try to keep the clearance in the forward clutch below 30 thousandths if at all possible. So like I said, we're going to install Alto Reds. Clean this backing plate off. And that should make for a nice clutch pack for this drum. Alright, so you're going to have two forms of sealing in the drums. You have the machine cut square seal on the piston, and then you have the O-ring that goes on the drum itself. And that's true of both of these drums. So just lube everything up, get it nice and saturated. Installing the pistons can be a little tricky. There's a certain way you can go about it that'll ensure that at least you have a reasonably good chance of getting it in there without struggling with it for an excessive amount of time. Let's go ahead and install your O-ring. Make sure it's all the way in the groove. Alright, lube that up as well. And then for your piston, you always want to make sure that this bleeder bowl is functional. Okay, make sure it's working. If it's not, if it's stuck, shoot it with brake cleaner. That should, you know, clear out any gunk or any debris that's, you know, causing it to clog up. And then, if not, then replace the piston. All right, so the forward clutch piston, from what I've seen of all these C4s, has a little identifying, you know, white mark or paint mark here, and the direct clutch, that lip seal or machine cut seal does not seem to have it. So, you know, we'll just match them up just like it did, or like they were when this thing came apart. So again, be very, very generous with your lube. Okay, you also want to check the inner diameter of the sealing surface for the piston, for this and the direct piston. Yeah, just to make sure they're not scored up or anything else that would otherwise endanger the seal there. Alright, those out of the way. So what I like to do is I will go ahead and kind of start it and maybe get it like one side and then just kind of work my way around. And then go progressively until I can get this thing all the way to the bottom. And that's it. Okay, we're gonna air check this, and when we do the clearance measurement, we'll, you know, we'll put air in it. But what I like to do, at least with these Belleville style plate equipped drums, is use a dial indicator and just lift up on the clutch pack by hand, because there's a lot of flexing going on with this Belleville plate, and that could color the results. Alright, so we have the original factory plate that came in here. The previous builder elected to reuse it. That's not the end of the world, to be honest. You know, these plates can crack, they can break. I've seen them come in broken on C6s from time to time. I don't see it as often on the C4s. I don't know, it's probably sampling error. This is another plate that I tried to install on another C4, hence, you know, it's got a little, you know, I guess battle scars on it, but for whatever reason it wouldn't go in. So I'm going to try to install it here. It is brand new otherwise, and other than these, you know, little minor aesthetic imperfections, undamaged. So basically what you need to do is get your snap ring into the groove underneath, and then what I'll likely do is take a hammer and a flat blade screwdriver and just tap it in all the way around until it seats. Now this is the snap ring that was installed into the plate position, and this was the snap ring that was installed into the clutch pack position, in other words up here. So that's what we're going to put back in, just like that. And then just work it. I mean, you may be able to do this by hand entirely, but more than likely you're going to need to use a little bit of persuasion with a hammer and a screwdriver. Alright, so what I like to do is, I'm going to have to turn the camera to show you, is I'll put this against my belly, just like this, and then I'll tap on it. So I do it this way. Maybe that's a little bit better. All right, you don't need to go ape shit with it. Just some smart smacks, nice and firm, until it's seated all the way around. All right, don't be afraid to double check, but it appears to have been installed correctly. All right, so we have our support ring underneath, we have the Belleville plate. The conical side does face down toward the piston. I mean, I didn't mention that, but I guess I should have. And then for our backing plate, you want to make sure that the smooth side, or the side with the little indexing mark, faces you. Alright, so you have your apply plate. You're going to have a friction. There's 5 frictions and 4 flat steels in this particular clutch. And go with the steel and then frictions and steels until you run out of them. And I gotta keep a constant watch on battery power, because these cameras, man, they suck it up. They suck down the batteries dry pretty quick. I get usually about 20 to 25 minutes on a full charge. And that's basically it. Okay, so we'll have to measure that and see how it does. I'm going to grab the dial indicator. Alright, let me set it up and then I'll reorient the camera so you can see the indicator very clearly, and then we'll do a quick clearance check. Alright, hopefully you can see that. I'm going to focus on the indicator face itself, and then we'll go ahead and do measurements. So what I like to do with most drums is I'll measure 4 points of contact and take an average, and that'll be my clearance. You could do 2, you could do even 1, and I don't know that you're going to get any materially different results, but it's just for peace of mind, for my sake. That's why I like to do it. So anyway, make sure that the clutch is fully bottomed out, and then zero the indicator, and then just lift up. Alright, so we're about 23 thousandths, at least at this position, so that's what I'm going to mark. And that is horrific handwriting. But I'm going to just go and take 2 measurements for the sake of expediency. I'll measure all 4 off camera and then I'll bring you back. But let's go ahead and measure 180 out from the previous position. That's telling me 26. I want to make sure that the needle stops moving on me. $25 or 26 is what I'm seeing. Having trouble consistently returning to 0. Okay, I'm going to actually record that as 25. I think I may have been changing the results a little bit because I kept my hands on the clutch pack instead of letting it just drop. Yeah, okay. I'm going to call this 25. So I'm happy with the way this clearance is shaking out. When the transmission goes back in, whatever clearance you measured on the bench, it's going to open up a little bit. A couple thou, 2 or 3 thousandths. Sometimes up to 5 thousandths. Like in 4L60Es, for example, the 3/4 clutch, I might set it to like 30 thousandths. And in the very rare instances where I had comebacks, I'd measure the clutch clearance again in that pack, and it would tell me like 35 thousandths. So 37 thousandths. There is some growth that will occur. So if you're a tad on the tight side with this clutch, as long as you're in the 20s, in other words 21, 22 thousandths, I wouldn't worry about it. The clutch just has to move and has to have some space so that it does not want to apply or come on when you're in park, neutral, or reverse. I mean, that's basically all you need to worry about. So when it's nice and tight like this, it reduces a lot of the stress on this Belleville plate, and that's what you want. I'll put that over there. Now we'll deal with the direct clutch. And let me raise you back up again so you can see into the, into the drum. Okay. So direct clutch is more or less the same story when it comes to what you need to do for your seals. So O-ring for the drum, and then a perimeter seal that's square machine cut for the piston. All right, again, check your inner diameter, run a finger. If you want to use your bare hand or bare finger to see if there's any scoring, and if you could feel anything, then do that. This piston appears to be okay. All right, I gotta get that snap ring out of there. Okay, for the direct drum, you could be a little bit more lenient on the clutch clearance. So, for example, if you want to do something like, I would say 30 to 40 thousandths for a 4-clutch drum. I think that's a good standard to manage to. As I struggle with the snap ring, it just does not want to come out. Come on. There we go. At least get in behind it. So these are selective as well. I think there are 2 more or 3 more available thicknesses for the forward clutch compared to the direct clutch, but I don't know that for 100%. I will flash a chart onto the screen if I haven't done so already that shows you all the different thicknesses available for these 2 drums in terms of the snap ring. This one looks like it's 72 or 73 thousandths thick. So that's what we have to work with. I don't know of a good source retail-wise for selective snap rings for these transmissions. I just go to my hard part supplier or into the junkyard, and I'll tear down C4s, at the junkyard and harvest things like this. Or my hard part supplier will have, just like a miscellaneous bin for stuff that I guess otherwise isn't cataloged and inventoried with its own individual line item. And so a lot of times there'll be selective snap rings from the drums there. Sometimes they'll have them in the drums too. You just buy the whole drum and the clutch pack's already set up and you're done. You just put new frictions. Alright, so direct piston you're going to install pretty much in the same fashion as the forward piston. Okay, plenty of assembly lube. These older pistons, they have 8 return springs. The 70 and up, I think, they went to like 1 single large return spring assembly. So, pretty easy deal. Alright, and then you have whatever configuration in terms of return spring. You'll need to install this onto a foot press or an arbor press or a shop press. I use a shop press, and compress these springs so that you can install the snap ring. There you have it. Well, maybe. Come on. There you go. Alright, so when you install the snap ring, you want to make sure that you're engaged on all 4 locking bosses. So the snap ring would be in a position just like this. Just like that. Alright, let me go to the press, install this, and then we'll be back and put the clutch in there and see what we end up with for clearance. Alright, back on the bench. So here we have our steels and our backing plate. So now we gotta make a decision on which friction module to use. We have 3 options. We have the factory spec type frictions. Okay, these were in there initially, and if you look at them in terms of their condition, they're essentially in perfect shape. Like if this is what you had and you were on some kind of extreme budget and your frictions look like that coming out, you could certainly reuse them. Maybe the transmission had another reason for coming out, you know, some other failure elsewhere that had no impact on the direct or forward clutch pack for that matter. Maybe that's what happened in your scenario, or a scenario. Alternatively, we have our other two frictions with upgraded clutch materials. So in this case, I have 3 Alto high energy frictions and an Automatic high energy friction. The Automatic clutch has a waffle pattern, whereas the Altos are all grooved. Does this matter? No, not one bit. Believe it or not, I mean, I wouldn't necessarily advise you to do this, but let's just say you had 5 different or 4 different brands of friction on the bench, and you just, you know, assuming they're all the same thickness of friction, 78 thou. If you wanted to put 1 friction of each brand in your drum, you could do it and it'll work. Like I said, I wouldn't, you know, I wouldn't instruct you to do that, but you know, if you were in a jam and that's your situation, you know, you could do it and it wouldn't be a problem. All right. I think I'm going to go with the Alto Reds. I mean, they're a great clutch, and we have them on the bench. You know, customers already paid good money for the unit, so let's go ahead and give him the best frictions we can, especially if he decides to, you know, upgrade the engine at some point in the near future. I mean, it's said to make about 300 horsepower, but, you know how it is when it comes to engines and hot rods. There's never enough power. So he builds Ford vehicles all the time. He specializes in trucks, but you know, he also does classic Mustangs and Thunderbirds and things of that nature. You know, he's a big Ford guy, so he knows his way around these vehicles and he knows his way around engines. So I wouldn't be surprised if he at some point did decide to do something a little different. All right, so you have your little ID mark or whatever you want to call it. That faces you. So a lot of builders like to run this clutch reasonably tight as well. Both the C4 and the C6 like the direct clutch reasonably tight. Okay, this looks like it's about 40 thousandths. The E4D's 4100, the direct clutch needs to be a little bit larger in clearance, you know, more clearance. And so makes it a little bit of a departure, especially given that the two transmissions essentially use the exact same drum. Alright, so what I'm going to do is I'm going to use some feeler gauges to do a preliminary measurement. And I'm going to choose 30 thousandths, just, you know, an arbitrary minimum. I think there's more than 30 in here, but let's see. So I'm going to start at 180 out of the snap ring. Alright, so that easily slides under. I'm going to zoom in a little bit. So now I'm going to go to 40 thousandths and see where that gives me. So I'm going to do 20 and 21 on my gauge set here. 20 thou feeler gauge and a 21 thou feeler gauge. If I can get my hands on the 20 thou feeler gauge, that is. If I cannot, then well, it means I'm the clumsiest transmission builder ever. Alright, 40 thousandths is starting to compress the pack. So you notice when I put the 40 thou gauge, you see a little bit of downward movement on the backing plate. See that? Okay, we didn't see that when we did 30 thousandths. So, a priori, this looks like to be 40 thousandths. Now, when I fire up the air compressor, we'll know for sure. We'll put the dial indicator on it and check it through the pump. But preliminarily, it appears to be in that 40 thou neighborhood, which I'm fine with that. So this thrust washer goes on the forward drum. I should have mentioned that when I was building it up. It goes right here. Alright, now, in the event you were a little loose on clearance, the aftermarket does make over-thick steels, or oversized steels, that's what they call them, but they're thicker by about 10 to 12 thousandths. These are both 90 thousandths. I think you can get even like 95 to 98 thousandths versions, and you can install them in whatever position, but my preference is to install thick steels, if I'm going to do it, somewhere in the middle of the pack. You can put, if you have to go in the other direction, install thin steels for whatever reason, and then this is true of any transmission, you want to put the thinnest steel on top of the piston. And the reason for that is because the piston, especially if it's aluminum, is going to be cooler than the friction disc that's on the other side of it. So at least you have one half of it that is markedly going to be cooler than the other's half, or the other side. So if I was to place this steel in here, go right in the middle, because that's where most of the heat is generated in a clutch pack. So just, you know, I guess a quick tip there for you when it comes to mixing and matching different thicknesses of steels in a given clutch. Alright, we've got shop air turned on, so what we're going to now do is measure clearance in our direct clutch and record it for official, you know, purposes. This is going to be our feed. I'm using about 50 or so psi air. 30 to 50 is more than sufficient. You don't need a lot. And then what we're looking for here is somewhere in the neighborhood of 30 to 40 thousandths. So I'm going to take two measurements initially. I got one by the snap ring. We'll do 180 out of the snap ring, you know, where the two ends meet, and then we'll see what we have and go from there. So that's 50 thousandths. And the air you're hearing is because this channel is not like a, you know, it's hard to create a perfect seal even with the rubber tip nozzle. Just by the way it is, it's kind of angled. So the sealing rings don't check that poorly when it comes to air. Alright, 50 thou is like 10 thou more than what I would like to see. So it's like 48 because it's returning to 1 below 0. So 48 thousandths. You want to make sure you work this clutch too before you actually take measurements. But I did that off camera. So if you do that, whatever measurements you have are going to be fairly accurate. So this is like a average of 49 thou. So we have our thick ass oversized steel plate. Very handy to have in this situation. So sorry about all the background noise. It's Monday morning. Folks that don't work at home are, you know, shuffling off to work, wherever it is that might be. I'm too lazy to take the drum off, so I'm going to use magnets to pull these frictions and steels out. The top friction, top steel, second from the top, and it's going to be this steel right here that I swap in exchange for the overdrive, or excuse me, the overdrive, the oversized steel. Yeah, you didn't know that the C4 had an overdrive clutch? Get in there. Alright, so for just the sake of thoroughness, let's measure our snap ring. 70 thousandths, 72 thousandths, 72 thousandths. If I had already done that, I apologize. I think I measured the forward clutch snap ring, or maybe I didn't. Maybe it was this one I measured. I don't know what the thickness of the forward clutch snap ring is. It's a little thicker than this. I would say it's about 90 thousandths or so. Alright, that looks a little more favorable, so let's see what we end up with. Alright, we're at 0. So I can focus in on that dial indicator so that you can absolutely see it. It gives me 32 thou. Turn into 1 below 0. That's 30 thousandths, 31 thousandths. So it's go 180 out. $32 thousandths. I like that. So I'm satisfied that clearances in this thing are what they need to be. So previous builder elected to keep it at 50, which, you know, I guess is fine. Like I said, 50 is max spec. However, pursuant to what I mentioned earlier about clutch clearance growth compared to measurements on the bench, once the transmission starts working in the vehicle, I would have put either a different selective snap ring in this clutch, or what I did, much thicker overdrive, oversized steel. So, and thereby you convert your C4 to an overdrive transmission just like that. It was only as that simple. Alright, those two are done. So now what I want to do is walk you through the process to select your number 1 thrust washer. Alright, so let's get that out of the way. Put this back in the drawer. We'll bring our completed drums over. Pardon me. Okay, you don't need to have this thrust washer in here for this, and that's why I wasn't in there initially. So we have our 3 drums, or excuse me, our 2 drums and our pump. I guess if you want to call the pump a drum, you can. It would be a little bit confusing for everybody else, but, you know, if you want to do it, it's up to you. So, what we need to do is first install our forward drum into the direct drum. Make sure it's all the way seated. Then we're going to flip the 2 on the bench. Alright, make sure you have some assembly lube down there at the forward drum inner diameter where the sealing rings go, and same for the direct drum. Now what we're going to do is install the pump into the drums, but first we have to install our number 2 thrust washer onto the back of the stator. So I'm just going to lube up the sealing rings. I mean, it's always good to have lube because then when you air check, you get a little bit more positivity. The cast steel sealing rings air check pretty well. The scarf cut rings are a little bit more leaky when you're using just air. So here is our little lube orifice. So we want to make sure that there's a cutout. So this one or the other one. And that's how we want it. Okay. We're not going to put a thrust washer here because we have to confirm or deny that this one is going to be acceptable. Now, in my teardown video, I showed this exact same process, and I strongly recommend that you follow this process, or you do this procedure when tearing the transmission down before you take apart the pump and the drums, because you'll know right away what your baseline measurements are going to be when it comes to setting or measuring your end float, as well as what number 1 washer you're going to be using. So you'll also be able to tell somebody set up the the front here incorrectly using the wrong washer. Alright, so now what I'm going to do is I'm going to lower the camera so that you can see edge on between that gap that exists now between the back of the stator support flange or thrust surface for this washer and the direct drum, because that's vitally important, and that is the spacing or the gap that we're looking to manage to when it comes to selecting this washer. Alright, I think I have you where I want you. So what we're going to do is we are going to eyeball the gap that exists between the thrust surface on the back of the stator support and the corresponding thrust surface that exists on the direct drum. And we want to insert our thrust washer in here so that we could see to what extent this thrust washer fills this gap. But what we don't want to see is the thrust washer have an interference fit, meaning it's going to start lifting the pump off of the drum, if you have to force it in there. Because if you have to force it in here, then you know that you've selected too thick of a number 1 washer. So I'm looking at this, and as you can see, it's fitting quite nicely. In other words, there's not a tremendous amount of space between the top of this thrust washer and the flange there on the pump. I'm thinking that gap's probably no more than about maybe 15 thousandths. So I could zoom in on it. Looks like it's about 15 thousandths, maybe 20 at most. I mean, I guess you can get some sort of device to measure that, but I don't have one. I mean, feeler gauges could probably do it if you have a set of feeler gauges that are long enough that can get up in there. It's not so much the actual measurement that's important. What's important is that this thrust washer does not change your overall infloat. And basically, in the case of this procedure, it does not force the pump up off of the direct drum. All right, now if you had too little of a gap, you know, we'll pull like a 76 thousandths thrust washer and put that in there. Get it over here actually so you can see it better. Okay, that's obviously way too much. You have way too much spacing there. So you would just simply select a thicker washer. The goal here is you want to get close to the actual space without going over. So think of it in terms of Price is Right rules, right? If this is going to be the gap itself is going to be the actual price of the item, this is going to be your best guess. You want your best guess to be as close to the actual price without going over. So, like I said, the previous builder set this thing up correctly. He did a good job. So we're going to basically retrace his steps in this regard without deviating. There's really no reason to, assuming that his end-float measurement stays true once we have the case assembled. When I measured it, it was like 25 thousandths, which is right in the heart of the spec. 8 to 40 is the range you want to manage to when it comes to overall end float, which is by definition the gap that exists between that number 2 washer on the back of the stator shaft and the pocket there where the stator sits in the forward drum. Okay, with the preliminary selection of the number 1 washer out of the way, we can go ahead and remove the pump and assemble the front gear train / drum complex. So you're going to have your forward direct drum. You want to make sure you put your non-selective forward drum thrust washer on. So, you know, a little green assembly lube and then just put it on. If you want, you can go like this. And looks like the fart can is fired up. Dude's going to work, I suppose. Alright, so you're going to grab your planetary, your ring gear, and your sun shell. So you want to make sure that when you install your bushings, you check for fitment. So like here on the sun shell, this fits like a glove. Nice and smooth. If you're bound, you need to clearance the bushings. Very rare I have to do that with C4s. Very rare. One area where you might need to do it is the case bushing. On the other C4 video I have, the bushing in the back when I installed it was a little tight and I had to massage it with 400 grit, then 800 grit sandpaper. And I think I finished it off with something like 1500 grit. So very simple and straightforward to do, but you just want to be aware of it. You don't want the bushings going in bound. You know, you don't want them too tight. Alright, soak your planets in transmission fluid. These things take Dexmerk. You can put Ford Type F in there as well. It's up to you. Whatever you'd like to do. And then once this complex is put together, we can move on to prepping the case for buildup. Just mesh your sun gear and shell just like that. So the front of the case is ready to go in terms of sub-assembly, so now we can move on to the rear of the case. First, we need to do a couple of things, install the selector shaft seal, and then we can start with the case buildup, which will first consist of installing that cam, those stupid roller and springs. Once we have that all set up, then we can start piling in everything into the back of the case that needs to go in there, as well as the band, put the servo for the low reverse position on or in, and do our band adjustment.